In this video, we're going to look at interval notation. Right off the bat, interval notation is a way to summarize an inequality or a range of values. Let's go ahead and connect interval notation to inequalities first. In our first example, we have x is greater than 2. So we want to think of all possible values that are bigger than 2. So of course, 3 would be a number that is bigger than 2, but we should also consider other values between 2 and 3. They also would be considered correct. So aside from 3, we could consider numbers like 2.1, but we could also drill down further. For example, 2.0000001 is also larger than 2, not by much, but it does satisfy this inequality. So we need to think about how can we include all potential answers here? Well, one way that we can begin to look at this would be visually using a number line. So it would be near impossible for me to know the next largest number right after 2. So what I'm going to do instead to save my brain from sweating, I'm going to go ahead and put a bubble or an open circle over 2. So essentially what this means is I'm going to kind of start in that area, but I'm not including 2. If I were including 2, I would shade the bubble in. But for now, I'm essentially putting a force field around it. I can get really, really close to it, but I can't burst that bubble or that force field. All the values that are larger than 2 would lie to the right side. So I'm going to go ahead and shade my number line on the right. Also note that I included the arrowhead 2. So that means that all values that are starting right after 2 and going off to infinity count. So now we actually have everything we need to set up that interval notation. So when we set up the interval notation, we write the smallest value that we see first, then the largest value, and we're going to separate those two values with a comma. So the smallest value that I see with my shading is 2, and at this moment you might be saying, wait, you said that we can't include that. Hold on, I will explain. And then the largest value that I see is positive infinity. If you have a little bit of trouble writing positive infinity, just think of it as an 8 that fell over. So next, I'm going to go ahead and include a parenthesis next to the 2. This tells me that I'm going to get really, really close to 2, but I'm not actually including it. So it has the same meaning as our open bubble or our open force field. Likewise, we always want to use a parenthesis next to an infinity symbol, whether it's positive infinity or negative infinity. Essentially, we don't want to consider infinity as an actual number. It's just the idea of a number. For example, if you were talking with your friend and you were playing a game with them of who can guess the larger number, you all would play that game indefinitely because you could just keep one-upping each other. Please note that the rule of to infinity and beyond does not count as a number, so that would not give you, I guess, the final end game win. So let's go ahead and take a look at an inequality that includes the equal to portion. So x is less than or equal to negative 7. So this time, instead of putting an open force field around the 7, I'm going to include it. And the reason for this is if I were to put negative 7 in for x, so substitute that in, I would have negative 7 is less than or equal to negative 7. That is a true statement. While negative 7 is not less than itself, negative 7 is equal to negative 7. From there, we would want to know, well, where would all the other values be located on this number line that are less than or equal to negative 7? And that would be all the values to the left. Again, I'm going to shade in that arrowhead, which indicates that I'm going off to negative infinity. Again, I have everything I need now in order to write out my interval notation. So to write that out, we are going to write the smallest value that we see, that would be the negative infinity, up to the largest value that I see in my shading, which would be negative 7. As I had mentioned before, a negative infinity will have a parenthesis next to it. The negative 7 is a different story. So much like how a closed circle says, hey, this value needs to be included in your solution set, a bracket will tell us to make sure that the negative 7 is included and accounted for in our solution. Finally, let's go ahead and take a look at a compound inequality. This one in particular is going to be 1 is less than x is less than or equal to 4. Another way to read this would be to say x is in between 1 and 4, where 4 is included. The idea of included is coming in because of the equal to in that less than or equal to symbol between it and the variable x. So this time on my number line, I went ahead and I just indicated where 1 would be in relation to where 4 would be. I'm pretty sure and confident that we all know how to count and that we know that 2 and 3 are sitting in between them. So here's what we are going to go ahead and do. First, we're going to note the inequality symbol between our variable and 1. It's strictly less than. In other words, by strictly I mean there's no equal to component to it. So because it's strictly less than, I'm going to put a bubble over it. Likewise, for the inequality between x and 4, this is less than or equal to. So that means I'm going to use a closed circle. So now we need to figure out where to shade. So in this case, we're saying essentially all the values that I am looking for are in between 1 and 4. So this is why I'm going to shade everything in the middle. And if you're still not certain, let's talk about that a little bit further. So we can do this by randomly picking numbers out of each of the sections that we see here. So I'm going to pick 1 maybe all the way on the far left, 1 in the middle, and 1 on the far right. So for example, let's just work with the number 0 and put it into the inequality. 1 is less than 0 is less than or equal to 4. And again, let's look for, I guess, false statements. And we can note it here right away. 1 is not less than 0. So this is why we did not shade anything in this section. Let's go ahead and pick something on the far right. So in this case, let's pick 12. I'm just picking that one arbitrarily. So this time we'll have 1 is less than 12 is less than or equal to 4. And while I do agree in the first part of this, 1 being less than 12, that's true. 12 is not less than or equal to 4. So because of that false statement, the entire inequality fails. So again, this is why we are not shading anything on this far right. However, if you were to pick anything in the middle, we would have true statements. So for example, let's say we pick 2.5. So we would have 1 is less than 2.5, which is true, and 2.5 is less than or equal to 4. That's also true. Likewise, say we just pick 4. We could do 1 is less than 4. Yeah, that's true. And 4 is less than or equal to, emphasis on the equal to, 4. So now let's actually go ahead and write that interval notation here. So in this situation, we are going to look for the smallest number that we have dotted or shaded. In this case, we have 1. The largest number that we have dotted or shaded is 4. And again, we're going to borrow from what we had discussed in the previous two examples. 1 has a strictly less than symbol. Also, it has an open circle. Those are connected, and that is connected to using a parenthesis next to it. Lastly, we have 4 is connected to a less than or equal to symbol, which brings us to a closed dot, which then leads us to a bracket. They're all connected. We're going to move into some examples where we would create histograms. So we're going to create our own bins or range of values in order to create a histogram. To reiterate, histograms use bins to group and organize their data. The width of each bin, or in other words, the range of values, should be the same. So for example, if we have one bin going from 1 to 5, we would want our next bin to go from 6 to 10. We would never want to create a histogram who has bins where one of them goes from maybe 1 to 4 and the other one goes from 5 to 17. The other note that we need to be aware of is that bins should never have any overlap or gaps. if there was overlap, then we may not know where to actually place certain values or how to organize it. We want to keep everything nice and clean and separate. So in this example, we're provided the test scores of 30 students, and our goal here is to take this information and create a histogram from it. In order to do that, we need to create some bins. When we create these bins, we want to make sure that they have the same width, or kind of essentially the same range. So for example, since we're talking about test scores, let's maybe look at one group that goes from 90 to 100. We want to replicate the width of this bin that we have here, but what we also want to be aware of is that we don't want any gaps in between the numbers. So for example, my next bin should not go from 79 to 89, because technically, even though we don't see it in this particular data, but maybe you have a professor who offers a decimal value beyond that score, so maybe like a 89.7, for example. Notice that it wouldn't fit in the lower bin from 79 to 89 because 89.7 is bigger than this range, and 89.7 wouldn't fit in the top bin because 89.7 is less than 90. So how do we fix that? Well, we're going to rework that second bin. The second bin I'm going to work with is going to be from 80 to 90. Of course, this does prompt a new question. Okay, but what happens if I do have a score of 90, which if we go into our list of data, we do see that 2 students scored 90% on this test. Where do they go? Do they go in the top bin? Do they go in the bottom one? Or do I split them? Here's how we're going to get around that. This is where we're going to use our parentheses or our brackets. So remember that if I use a bracket, for example, that means that we get to include that value into that range. If I use a parenthesis, however, that tells me that I can't quite use that data value. So I can't put 90 into this bin, but anything that is even ever so slightly bigger than 90 can go into this bin. And again, what we will go ahead and do is we'll replicate that below. So the 90 in the second bin will get the bracket, and then that 80% will get the parenthesis. So now notice that, for example, the students who scored 90, we know that they won't go in the first bin because that parenthesis next to the 90 says you can get really close to 90, but we're not actually working with 90 here. They would both go into the second bin where the bracket is next to 90 saying, hey, it's included in here. So now we definitely don't have any overlapping and we don't have any gaps now, which is great. So let's go ahead and continue to create this list. And if you want to pause the video really quickly and fill that out for yourself, please go ahead and do that. Here is what we should have. I made my last bin only go from 20 to 30 because I noticed that no student had earned a score below 20 here. You could have continued to make those bins, but you just would have had 0 in them. So going through, we can kind of color code this, for example, and we can begin to find out the counts for each of these bins. So if we look at the bin for 90 to 100, again, that means I'm looking for scores that are larger than 90 and can go up to 100. So we have, it looks like 1, 2, 3, and 4. So I would have a count of 4 here. Coming down to the next bin, going from 80 to 90, again, notice that I'm looking for scores that are definitely larger than 90, but can be equal to, here is what we should have. Notice that the last bin that I created only goes from 20 to 30, and that's mainly because I don't have any students who scored below that, so there isn't a need to create any other bins here. So let's go ahead and begin to fill in how many data points go into each bin. So looking at the top one, we're looking for scores that are bigger than 90 and can be as large as 100. Remember that since the 100 has the square bracket, it means that anyone who scored a 100% would definitely fit into this grouping. So going through my list, I'm going to circle anything that's bigger than 90 or could be as large as 100. So I have 1, 2, 3, 4 scores. Remember that 90 doesn't fall in here because 90 has the parenthesis next to it. So that means I can get really close to it, but I cannot include 90 in this situation. That's why we created the second one with 90 with a bracket. So now we're going to go ahead and we're going to look at any scores that are larger than 80 and can go up to and be as large as 90. So we've got 1, 2, 3, 4, 5, 6, 7, and that's it, 7. So go ahead and pause the video and fill in the rest of these bins. So here are our final results. So finishing the other bins, so from the 70 to 80, we would have 3 scores. 60 to 70, we had 4. 50 to 60, we had 4 again. 40 to 50, we had 3 scores. 30 to 40, we had 2. And then 20 to 30, we had 3 scores. So we would take this information and we would create the following histogram. So as you can see, I've made sure that the axes have been labeled. So the vertical axis is referring to the frequency or the count of those scores. And then we have the test scores listed on the horizontal axis. Notice that, again, there are no gaps in between each of the columns, or in other words, which are representing the bins. And again, that was because of how we had created our intervals. There was no need to have any kind of gap or bin because we were using our bracket and our parenthesis. And again, if you were to count each of these columns using the right side or the vertical axis in order to do those counts, we would see that these bins would still total out to 30. And again, we had 30 data points. So before we conclude this video, let's look at one more example. This time we're going to look at the weights of 20 house cats in pounds. Also notice that in this situation, we're going to work with values that have decimals attached to them. So this time, instead of starting my bins going from largest to smallest, I'm going to start with the lightest house cat and then build up. Remember that when we're creating our bins, we want to make sure that the widths are going to be the same from bin to bin. So for example, I'm noticing that the lightest cats in here, they seem to be around 5.2 pounds. So I'm going to make my one bin start at 5 pounds, and I'll have it go up to 6 pounds. And again, when we're creating these bins, we want to make sure that there are no gaps, and we also don't want any overlaps. So in order to avoid gaps, for example, I wouldn't want my next bin to start at, say, like 6.1 pounds, because again, what happens to the cat that's maybe weighed and is like 6.05 pounds? There's no home to place that cat, and honestly, that's sad. So what we would want to do then is we would start the next bin at 6. However, we want to make sure that should we end up having a cat that is exactly 6 pounds, we need to know where to put that cat. We cannot put the cat in both bins because you can't multiply a cat like that. So again, that's where your parentheses and your brackets can come in. So in this case, I might put a parenthesis next to the 5, and I'll put a bracket next to this 6 pounds. So that means for my next bin, I will put a parenthesis next to the 6 as well. This then means that because I want to keep the bin width the same width, I'm going to go up 1 pound to 7, and I'll include that. And then again, I will continue to do that. After that, I can go ahead and take the counts and place those cats into the appropriate bin. Go ahead and pause the video, give this a try, and when you're ready, press play and we'll review the solution. Here are our results, and just as a reminder, just to make sure that you have taken into account all 20 cats, you can go ahead and total out all the counts that you have within each bin, and it should come back to 20. So if you ended up getting like 19, for example, you have neglected one of your cats. If you got 21, somehow an extra cat got into the mix. So this actually serves as a great way of checking to make sure that you have most likely subdivided your data into the appropriate bins. All right, that's it. Thank you so much.